Hello, good morning, good afternoon, good evening, everyone. It's my pleasure to be here today to discuss the full history of AI. Artificial intelligence or AI, as we already defined in the previous lectures, is the simulation of human intelligence in machines. And those machines, computers, phone, cars, or any device that has computational capacity are programmed to think, learn, and decide. So, main tasks like human think rationally, learn, it means they improve, and also they act, or you can say make decisions. The goal of AI, the ultimate goal, is to create systems that can perform tasks that they typically require human intelligence, such as visual perception, speech recognition, text generation, language translation, diagnosis, prediction, and such kind of tasks. The history of AI is a journey of innovation and discovery. So the history began with early philosophical and mathematical foundations, and those foundations lead to development of the first electronic computers in 1930. Over the decades, AI has evolved through various states, including the birth of neural networks, the rise of expert systems, and the recent advancements in deep learning and generative AI. Let's explore some key milestones in the history of AI. AI is an interdisciplinary field that draws from various areas of study, including philosophy, mathematics, economics, neuroscience, psychology, computer science, control theory, linguistics, and many others. In the case of philosophy, philosophy laid the groundwork for understanding logic, reasoning, and the nature of the mind. Then we have mathematics. Using mathematics, we can provide some tools for formal representations, algorithms, probability, and etc. Then, in terms of economics, economics contributed concepts like utility and decision theory. Neuroscience inspired the development of artificial neurons, while psychology and cognitive science help us understand how humans process information. Computer engineers and computer scientists and also control theory enable the creation of powerful machines and systems that maximize efficiency. Last but not least, linguistic like knowledge representation, grammar for natural language processing, these all contributed in the advancement of artificial intelligence. So let's go back in 1642. The journey of AI began long before the term was coined. In 1642, Pascal, this gentleman, he was a French mathematician, physicist, and philosopher. He invented Pascaline. Pascaline was one of the earliest mechanical calculator. The Pascaline was designed to assist Pascal's father, who was a tax collector. Pascaline could perform addition, subtraction through a system of geared wheels and was one of the first devices to use a carry mechanism for calculation. Despite its innovation design, the Pascaline was not widely adopted, and the reason was it was very complex and also limited need for such machines at that time. Next, in 1694, William Leibniz, he developed step-reckoner. Step-reckoner was an advanced mechanical calculator that could perform not only addition and subtraction but also multiplication and division. The step-reckoner was based on step drum mechanism. In 1805, this gentleman, he introduced the concept of least square method for data fitting. The least square method is a mathematical optimization technique, and it is used to minimize the sum of square difference between observed and predicted values. And it's a kind of fundamental tool in statistics and data analysis. So here you can see if these are our original data points, real data points, and these are predicted for this one, for this one, then we try to find out this error, right? This is called as error. So then we can have this line, right? And this A is called as intercept, and B is called as slope. So we want to find out A and B in such a way that this sum of error is minimized. In these days, this least square method is used widely in linear regression. Later we will study linear regression. Despite the emergence of advanced optimization techniques, this ordinary least square remains widely used due to its simplicity and efficiency, especially when dealing with small to moderate sized data sets. In modern machine learning, variations like ridge regression, L2 regularization, and also lasso regression, L1 regularization, extend least squares to handle multicolority and feature selection. Then in 1812, Bayes' theorem was introduced. To be specific, Thomas Bayes, this gentleman, he was in 1701 until 1761. He formulated the idea of Bayesian probability. The probability of A given B is equal to the probability of B given A multiplied by probability of A divided by probability of B. But his work was published after he did in 1763 by Richard Price. Laplace later independently developed and formalized Bayes' theorem in 1812, incorporating it into his broader work on probability theory. Bayes' theorem plays a fundamental role in probabilistic reasoning, statistics, and also modern AI, particularly in areas like Bayesian network, machine learning, and decision theory. This early mathematical innovation indeed laid the groundwork for AI by providing the tools for reasoning under uncertainty. Next, in 1913, we had Markov chain. Andrei Markov developed the mathematical framework for what would later be called as Markov chain. Markov chain describes a system that transitions between states with probabilities that depend only on the current state, not the previous state, and this is known as Markov property. These techniques have become fundamental in probability theory, machine learning, natural language processing, reinforcement learning, and many other things. So here you can see, for example, if today is sunny, by the probability of 60%, tomorrow is sunny. By the probability of 30%, it will be cloudy, and by probability of 10%, it will be rainy. Then if today is rainy, by the probability of 50%, tomorrow will be rainy, 10% it will be cloudy, and 40% it will be sunny. If today is cloudy, by probability of 30%, tomorrow will be cloudy, 50% rainy, and 20%. So this is based on data set. Markov chains are widely used in applications like speech recognition, text generation, weather prediction, reinforcement learning algorithm like Markov decision process, and these are very important in the advancement of AI. 1930s saw the invention of electronic computers. The computers provided computational power for advancements of AI research. These machines were the first step toward building intelligent systems. Those are capable of processing large amount of data. Then in 1943, Warren McCulloch and Walter Pitts introduced first artificial neural model, and this was known as MP neuron. This model was a simplified mathematical representation of biological neurons, and they use binary threshold logic to mimic neuron activation. So this MP neuron could perform basic logical operation like AND, OR, and NOT. So MP neuron could demonstrate that neural networks could theoretically compute any function. This work laid the foundation for artificial neural network and influenced later developments including perceptrons, backpropagation, and deep learning. So here you can see the model is almost like the biological. So these are the architecture of neurons in biology, like human brain, and this is what is called as neuron models. So in here you can see the input, some activation function, and output. Somehow they mimic the brain. In 1950, Alan Turing published the landmark paper, and it was Computing Machinery and Intelligence, this paper, and he asked one question: can machine think what humans do? So in this paper, Turing introduced the Turing Test. So the Turing Test, a method for evaluating machine intelligence. So in his test, proposed that if a machine engage in conversation indistinguishable from that of human, it can consider. It means if we have a conversation with one machine, but we don't know exactly this is a machine or human, it means that machine is intelligent. This concept remains influential in AI research, natural language processing, and human-computer interaction. So how this Turing test works? This is the Turing test. As you can see here, this lady is judge. This gentleman is in one room, and this robot, not robot, it's a computer program, you can say, in another room. This lady doesn't know who is where, doesn't know the man is here or machine is here. And she tried to communicate with them, right? It's a kind of conversational test to evaluate whether a machine can exhibit human-like intelligence. So in here, the judge interacts with both the human and AI through some text-based communication, chatting. Then the judge engaged in free-flowing conversation with both human and AI, asking various questions. The AI tries to mimic human responses while the human responds naturally. Then, for evaluation, after a set duration, the judge must decide which participant is the human and which one is the AI. If the AI can fool the judge into thinking it's a human, then boom, right? So you can say captcha that you can see when you are opening some website, they ask you to write down some text, some numbers, or they ask you to find some bicycles in image. So captchas on different websites are reverse Turing test. So computers try to distinguish between human and robots, or you can say bots. Oh, we come to the birthday of AI. The term artificial intelligence was coined by John McCarthy in 1956, and it was during Dartmouth Summer Research Project. This conference is considered at the birth of AI as a formal field of study. Happy birthday, AI. Then in 1966, Lotfi A. Zadeh, this gentleman, has introduced the fuzzy logic. Fuzzy logic was introduced in 1965 to be exact. And this is kind of extension of classical Boolean logic. Fuzzy logic introduced degree of truth rather than strict true or false, enabling AI to handle uncertainty and vagueness. In fuzzy logic, elements belong to a set with a degree of membership which is something between 0 to 1, not 0 and 1. In CRISP, we can say 0 or 1, but in here from 0 to 1. So for example, here we can say that this data here, so they belong to this set with this degree of, so from here to here 100% belongs to this set, and from here decreases. So this point here belong to set with 0%, right? If I want to give you an example, how do we define a person is tall? It's logic, right? Sometimes we say 170 is tall, sometimes 180 is tall, 200 centimeter is tall, right? But we have no exact meaning. But in case of fuzzy, we say that if someone is 180, and if the maximum height is, for example, 220 centimeter, then we can say, for example, 90% he is tall. Percentage, right? So fuzzy logic was widely applied in AI-based decision-making systems where binary logic failed. It was used in expert systems, robotic, image processing, consumer electronics like washing machine, air conditioner, and many other systems. One of the first AI programs to simulate human conversation was ELIZA. This ELIZA was developed in 1966 by Joseph Weisbaum, this gentleman. It was an early example of natural language processing, and it demonstrates how AI could interact with humans through text-based conversation. Then in 1968, Marvin Minsky and Dean Edmonds developed the first artificial neural networks. This was a major breakthrough in AI, and it showed that machines could learn and adapt from experience. By 1972, AI had moved from theory to physical systems. Robot 1 was developed in Waseda University in Japan, and it was one of the world's first full-scale humanoid robots, and it was developed by a research team led by Professor Ishiro Kato. During 1970s, AI research faced a significant decline, and this decline was due to the limited computational power, lack of data, common sense knowledge and reasoning. Governmental and corporations were losing faith in AI. This is called as AI winter. There were many reasons for this one. As I said, limited computer power, lack of data, and also funding costs from government and institutions, particularly in the US and UK, was very limited. Disillumination with AI progress, as early systems like rule-based expert systems failed to scale efficiently. And also computational and data limitations that restricted the feasibility of more advanced AI models. This period demonstrated that AI development would not be linear or straightforward. However, AI research revived in 1980s with the rise of expert systems, and again in 1990s and in the recent century with the advancement in machine learning, neural networks, and computational power. So the Stanford card was introduced in 1979. It was an early autonomous vehicle developed at Stanford University. It became one of the first self-driving robots to successfully navigate a complex obstacle course during using computer vision and AI-based decision making. Here you can see the Stanford card. The card used a single black and white TV camera, and this TV camera takes image from multiple angles, allowing the system to analyze depth and detect obstacles. The Stanford card moved extremely slow, taking around like 5 hours to travel just 20 meters. Then in 1980, we had expert systems. AI regained momentum in 1980s with expert systems. Expert systems were programs that designed to mimic human decision making. Expert systems were designed to solve complex problems by reasoning through bodies of knowledge represented mainly as if-then rules. These systems were widely used in medicine, finance, and engineering, and they tried to prove that AI could solve complex real-world problems. Backpropagation was introduced in 1986, and it revolutionized neural network training by enabling efficient weight adjustment through error propagation. So in here, using forward propagation, they try to compute the output. Then using a loss function, they try to find what is the difference, how much is the difference between the predicted value and the actual value. Then using backpropagation, they try to adjust weight and biases to minimize the error. So backpropagation, it's a kind of supervised learning algorithm. And in here, we use gradient descent method or some other optimization methods. And the objective is to minimize the error by propagating it backward from output layer to the input layer. Then backpropagation updates the weights of neural networks. How? by computing the gradient of the loss function concerning each weight. We can say del of j with respect to del of wij at layer L. In this way, we try to do it. Then we make a new weight. For example, new weight is equal to the old weight minus alpha into of j cost function, right? So new weight is equal to the old weight minus alpha. This is called as learning rate, and these are the gradients, right? In this way we can do it. Despite its success, backpropagation limitations such as vanishing gradient in deep network leading to development of advanced techniques like ReLU activation, batch normalization, and residual connections. A major breakthrough came in 1997 when IBM Deep Blue this Deep Blue is managed by IBM, could defeat world chess champion Mr. Garry Kasparov. The game was like this. There was a computer here, and this gentleman is Garry Kasparov, the world champion of chess. So this tells this gentleman how to move. Finally, it defeated. This was a defining moment, proving that AI could surpass human intelligence in specific tasks. So Kasparov won the 1996 match, but in 1997 they upgraded Deep Blue and the machine could win. AI began entering homes with products like Roomba, and this Roomba is autonomous robotic vacuum cleaner, and it was achieved in 2002. Such advancement demonstrated AI's potential in everyday applications, making technology more accessible for publics. So Roomba sensors could detect the presence of obstacles, detect dirty spots, and sense steep drop to keep it from falling down a stair. 2011 marked a transformative decade for AI, with breakthroughs that demonstrated AI's ability to tackle tasks once thought to be exclusively human. IBM Watson defeated human champion in Jeopardy. So this Watson did it by leveraging natural language processing, machine learning, and vast knowledge retrieval. This Jeopardy was a special man vs machine competition that it was in February 2011. The AI competed against two of these great champions. So Watson used natural language processing to understand Jeopardy style questions. Then Watson processed massive amount of data but was not connected to the internet. Watson relied on extensive internal knowledge base. So Watson answered questions in real time by ranking possible responses and selecting the most. So someone asked question, and compared to these two gentlemen, the Watson won the game. Then in 2011, Honda company, Japanese company, introduced ASIMO. ASIMO was their advanced humanoid robot featuring the world's first autonomous behavior control technology. ASIMO could recognize its environment, predict movements, and make decisions without direct human control. ASIMO could run at 9 km per hour, walk on uneven surfaces, and even jump. ASIMO could recognize multiple voices, respond to gestures, and shake hands naturally. Also, it could perform complex tasks like opening a bottle and pouring a drink, showcasing fine motor control. So this ASIMO set a new standard for humanoid robots. And next, we had Google Brain. In 2012, Google Brain, it was led by Jeff Dean, Andrew Ng, and Greg Crado. They developed deep neural network that significantly advanced unsupervised learning and pattern recognition. The deep neural network was trained on 10 million YouTube videos and this algorithm learned to recognize cat without explicitly labeling, and it showcased unsupervised learning capabilities. The network leveraged Google's large-scale computing infrastructure by combining machine learning and distributed systems. The research demonstrated that deep learning could autonomously extract high-level features from raw data. So in this example, you can see that object detection using this model. AlexNet, developed by Alex Krzyzewski, Ilya, and Jeffrey Hinton. This Jeffrey Hinton, often referred as the godfather of AI, and he was awarded Nobel Prize in 2024, Nobel Prize in Physics, alongside with John Hopfield for their foundational work in AI. So AlexNet demonstrated that deep convolutional neural networks outperform traditional feature-based methods in image classification. AlexNet used NVIDIA GPUs to train the network, drastically reducing training time and improving GPU effectiveness in deep learning. They also introduced ReLU, rectified linear unit, and this ReLU sped up training compared to sigmoid and 10H function, and also it prevents vanishing gradient descent. In 2014, Facebook AI research introduced DeepFace. This is a kind of deep convolutional neural network for facial recognition, and it could achieve human level accuracy. DeepFace achieved 97.35% accuracy on the labeled face in wild dataset, and it's a kind of approaching human level performance. DeepFace used a 9-layer deep neural network trained on 4 million images. In 2014, the chatbot Eugene Goostman designed a simulate of 13-year-old Ukrainian boy, and it became famous for passing the Turing Test during a competition organized by University of Reading. Eugene was programmed to have a non-native English background and a young age, and in this way it was easier to justify inconsistency in responses. It convinced 33% of judges that it was a human, exceeding the 30% threshold originally proposed by Alan Turing. So then we had Google DeepMind introduced in 2014. This Google DeepMind was showing DeepQ network, DQN. It's a kind of deep reinforcement learning algorithm, and it could learn to play Atari video games from raw pixel data. Next, in 2015, Amazon introduced Amazon Echo. Amazon Echo was a smart speaker that revolutionized voice-controlled AI by integrating Alexa, Amazon AI-powered virtual assistants. For this one, users could speak to Alexa to perform tasks hands-free. It supported streaming from Amazon Music, Spotify, Apple Music, and many more. It was integrated with IoT devices like smart lighting, thermostats, and security system. Enable users to set reminders, alarms, and make lists and schedule alarms. This Amazon Echo played a crucial role in making voice control AI assistant mainstream. They also try to shape the future of AI driven personal assistant and smart home ecosystems. In 2016, DeepMind's AlphaGo made history by defeating Go World champion Lee Sedol. This gentleman is Lee Sedol from South Korea. And this DeepMind AlphaGo could demonstrate AI ability to surpass human intelligence in complex strategy game. Go game is considered as the most difficult strategy game in the world. So it's very complex and it has massive search space and deep strategic depth. Unlike chess, in case of chess, the complexity, or you can say possible positions, is 10 in power of 30, but in case of Go, the possible positions is 10 in power of 170. So making brute force approach impractical. So first AI defeat a professional Go player Fan Hoi, then defeated Lee Sedol in 2016, and finally in 2017 he defeated Ki Jie. It was top ranked Go player at that time. So AlphaGo was trained using supervised learning, human games, and also reinforcement learning. It means self-play. So Monte Carlo tree search also was used to evaluate millions of possible moves. So AlphaGo played millions of games against itself. AlphaGo victory over Lee Sedol in 2016 was a landmark event proving that AI could outperform humans in intuitive and strategical thinking games. In 2016, Boston Dynamics introduced Spot. A Spot is, as you can see in this image, is a four-legged robotic dog, and it's designed for agility, mobility, and adaptability in real-world environment. Boston Dynamics is a robotic company known for developing advanced agile robots like Spot, and in the next slide we have Atlas and also Stretch, and they are specialized in mobility, AI, and automation for real-world application. Korean company Hyundai is the owner of this Boston Dynamics since 2021. Spot moves through complex terrains like stairs, rocky paths, and industrial sites. It can pick up and move construction material using an optional robotic arm. It functions in rain, snow, and extreme conditions. If Spot falls, it can autonomously get back up and continue operating. Spot operates via a manual control or autonomous navigation using cameras and sensors. So the advancement of Spot by Boston Dynamics showcase the future of robotics combining mobility, AI, and autonomy for real-world application beyond factories and labs. Then Atlas was proposed by Boston Dynamics in 2016. It's a kind of very advanced bipedal humanoid robot. It has 6 feet can say 183 centimeter tall. Atlas was designed primarily for research and rescue tasks, and it is highly capable in navigating difficult terrain and performing various physical tasks. Atlas is based on Boston Dynamics' early Pitman, which was designed to simulate human movement for testing military clothing. However, Atlas was much more refined, featuring advanced agility and balance. In 2016 video released by Boston Dynamics, Atlas demonstrated its ability to run, jump, flip, and even recover from fall. The Henn Hotel in Japan, in Nagasaki, Japan, made headlines in 2016 for being one of the first hotels fully staffed by robots. The concept behind the hotel was to integrate advanced robotics and AI technology in order to provide a unique and efficient guest experience, and also they want to reduce human labor and cost. The check-in process was handled by humanoid robots, and also robots were used to offer concierge service, providing information about the hotel or recommending local attractions. The Henn Hotel remains a symbol of how robotic and AI could transform hospitality services, even if the initial vision was adjusted over time. Sophia, introduced in 2016, gained global attention as the world's first robot citizen. This is a title given to her by Saudi Arabia in 2017, and it makes her the first robot to receive citizenship from any country. Sophia uses advanced AI to recognize and process faces, and also it is designed to display a range of human-like facial expression. It uses natural language processing and machine learning to engage in conversations with humans. Sophia creation has sparked ongoing discussion about the potential of AI in social roles, and it can be somehow the ethical implication of robots having legal identities and rights. Then in 2017, again, generative adversarial networks reached a milestone in their development, with significant advancements being made in deepfake technology. GANs, introduced by Goodfellow in 2014, became more sophisticated and powerful in 2017, enabling the creation of deepfake. So deepfake are highly realistic AI-generated images, videos, or audio recording designed to alter or fabricate reality. GANs, generative adversarial networks, consist of two networks. One is called as generator, and another one is discriminator. This generator and discriminator compete against each other. The generator creates synthetic data like images or video, and the discriminator evaluates its authenticity by comparing it to real data. Over time, both networks improve, resulting in high realistic generating contents. The emergence of GAN and deepfake in 2017 signaled both the potential and risk of generative AI, highlighting the need for ethical guidelines and tools to detect and mitigate misuse in a variety of fields. transformers introduced in a paper titled "Attention is All You Need" was published. This paper was published by Vaswani and his friends in 2017, and they introduced a groundbreaking deep learning architecture for natural language processing. These transformers replaced recurrent neural networks and LSTM, long short-term memories, with a fully self-attention based model or mechanism. These enable faster training and better performance on sequence-based tasks like sentences and videos. The key innovation was the self-attention mechanism, and this self-attention mechanism allowed the model to weigh the importance of different words in sentence, regardless of their position. The transformer architecture led to development of state-of-the-art NLP models using BERT, GPT, and others. So you can see the structure here. We have input and output, and in a separate lecture we will study transformers. This paper marked a major milestone in AI, making large-scale language understanding and generation possible, and influencing breakthroughs in chatbot, translation, and generative AI. In 2018, Samsung Bixby was introduced. It's a kind of virtual assistant that combines voice interaction, camera-based vision, and smart home integration to provide a seamless user experience. Bixby, it's available on almost all new Samsung phones, allows the users to engage with assistant through voice commands, asking questions, making recommendations, or requesting suggestions. Bixby is integrated with the camera application, and this enables it for object detection, image search, purchase suggestion, translation, and landmark recognition. This ability helps users gather contextual information based on their surrounding. Bixby also supports smart home function and allows users to interact with applications like weather, fitness, and other home utilities. In 2019, AI named DABUS. DABUS was created by Stefan Thaler, and it was the subject of 2 patent applications. DABUS represents a novel approach to AI-driven innovation, and in here, neural networks generate new ideas by altering their interconnections rather than simply being programmed to solve predefined tasks. The 2 patents are a new type of beverage container and also a device for attracting enhanced attention. In the case of beverage container, this innovation is based on fractal geometry, and it offers a unique design that likely provides efficiency in storage or handling through patterns found in nature's repetitive structures. The second one was a device for attracting enhanced attention. This innovation was proposed for use in search and rescue operations, where a device could help in attracting attention in emergencies, for example, using innovative patterns or signals to make it more visible or recognizable. These applications were groundbreaking in that DABUS was listed as the inventor, sparking debates about intellectual property rights and whether an AI can be credited as an inventor. So far, the achievements of AI were 1 or 2 per year, but from 2020, we had too many achievements in a year. That's why we present many in one. So 2020 can be called as the year of language models. GPT-3 was introduced by OpenAI. It is a powerful language model and it is capable of generating human-like text, advancing NLP and AI capabilities. Then AlphaFold was introduced by DeepMind. It could solve the protein folding problem. It was a big challenge in biology. Then we had too many COVID-19 AI applications. AI models were developed for diagnostics, drug discovery, and vaccine developments. Tesla FSD, full self-driving beta, was introduced as a major progress in autonomous vehicle technology with public testing of Tesla full self-driving feature. And also we have AI art, the emergence of AI generated artwork sold in prestigious auction blending AI with creativity. Then in 2021 we had the year of creative AI. AlphaGo by DeepMind was introduced. AlphaGo demonstrated the ability to solve programming problems at a level competitive with human coders, and it showcased a significant step forward in AI for software development. DAL-E was introduced by OpenAI. This DAL-E is an AI model capable of generating creative and diverse images from textual descriptions, push the boundaries of visual creativity using AI language models. Then we had AI in climate science. Many AI models were applied to predict climate patterns and optimize energy use. Next, in 2022, we can call the year as the year of conversational AI. GPT 3.5 introduced in 2022 by OpenAI. This improved upon GPT-3 and it was with enhanced efficiency, better contextual understanding, and faster response times, serving as a bridge to the more advanced GPT-4. Lambda was introduced by Google. Its language model for dialogue applications, and it made waves with its conversational abilities, promising a new era in chatbots and virtual assistant technology. Codex was introduced by OpenAI. This the model behind GitHub Copilot. It's a kind of revolutionized coding by assisting developers with code generation, further blurring the line between human creativity and machine-generated work. We had too many models in healthcare, like AI-driven tools demonstrated major progress in medical imaging, disease detection, and even predicting patient outcome, further transforming healthcare systems. 2023 is called as Year of Multimodal AI. ChatGPT-4 was released by OpenAI. GPT-4 demonstrated far superior reasoning capabilities and multimodal abilities like text and image processing compared to the previous one, marking it as a substantial leap over its predecessors. AI-driven drug discovery. AI in 2023 played a crucial role in identifying novel drugs and therapies, especially in complex diseases like cancer, reducing their timeline for drug development. And we had very big advancement in autonomous vehicles. Progress in fully autonomous vehicles saw advancement with public rollouts of fully self-driving cars in certain regions although regulatory hurdles remain. Then in 2024, the year of generative AI in industry, AI in creativity, AI music and design, the line between human and machine creativity blurred further, with AI generating high quality art, music, and literature. AI for quantum computing was highlighted in 2024. AI made breakthroughs in optimizing quantum algorithms, speeding up the practical use of quantum computers in solving complex problems. AI driven sustainability. AI driven solutions contributed to major breakthroughs in clean energy, climate forecasting, and carbon capture, and they play a crucial role in global sustainability efforts. Cloud 3 was introduced in 2024. It was developed by Anthropic and released in 2024. It's a kind of advanced AI model and it is mostly known for its enhanced reasoning, contextual understanding, and improved safety features in text generation. And also we had Google Gemini 1.5. It's a kind of multimodal AI model that excels in text, image, and code processing, featuring an extended context length for better comprehension and reasoning across complex tasks. Then the current year, pioneering innovation and transforming industries. We have so far AI in general purpose robotics. By 2025, advancement in robotics powered by AI lead to more autonomous and versatile robots capable of performing complex tasks across various industries. We had too many AI enhanced personalized medicine, like enable truly personalized healthcare by analyzing vast amount of genetic, environmental, and lifestyle data. Also, we have some progress in AGI, artificial general intelligence. While this general artificial intelligence or AGI remains a long-term goal, progress toward more flexible, adaptable AI system likely increase in this year. And also AI for governance. AI may play a larger role in governance, assisting in decision making, policy formation, and even public services with potential ethical concerns. In this slide, I want to take you on a journey through the landscape of AI capabilities from simplest tasks at sea level to the most challenging at the peak. Abstract thinking. At the lowest level, we have like rote memorization, vision, and translation. These involve recognizing pattern and repeating information. AI systems have mastered this task efficiently. They can handle image recognition, basic language translation, and speech recognition with remarkable accuracy. Moving forward inland, we encounter slightly more skills such as driving, investment vision, and playing games like Go, Jeopardy, chess. These require reasoning, learning from data, and adapting to new scenarios, making them significantly harder than basic recognition. As we ascend into field, we reach social interaction, management, and cinematography, areas requiring deeper contextual understanding, creativity, and nuanced decision making. AI has made progress here, but human expertise remains dominant. Beyond this, we enter the steep mountain of AI challenges like programming, theorem proving, book writing, and AI design. These require complex logical reasoning, problem solving, and creative generation of new ideas. AI can assist in these areas but has not yet reached fully autonomy. Finally, at the summit of this landscape stands abstract thinking, the most difficult challenge for AI. What is abstract thinking? Abstract thinking is the ability to understand ideas, concepts, and patterns that are not directly visible or tangible. For example, you say time is money. Proverb, right? Time is money. It means time is valuable, or understanding that this heart represents love, or you can say poem, right? These are abstract thinking. This includes high-level scientific reasoning, theoretical discoveries, and deep conceptual understanding. True abstract thinking requires the ability to generalize across domains, create new paradigms, and understand meaning beyond raw data. While AI continues to advance, we are still far from machines achieving this pinnacle. So, what about the future of AI? Democratization of AI. AI tools and knowledge becoming more accessible, empowering individual and small business. Think of no-code AI platform and readily available pre-trained models. Explainable AI moving beyond black box AI. Focus on understanding why AI makes certain decisions, increasing trust and transparency. AI augmentation and no replacement emphasize on AI collaboration with humans, enhancing our abilities rather than replacing us. Examples include AI assistants for professional and personalized education. Rise of specialized AI, shift from general AI to specialized system designed for specific tasks. Think AI for drug discovery, climate modeling, or personalized education. Each AI processing data closer to source, for example, on devices, and this enables faster and more efficient AI application. These are essential for IoT, autonomous vehicles, and robotics. Focus on ethical consideration, growing awareness of bias in algorithms, privacy concerns, and the societal impact of AI. Then we have quantum computing and AI. This potential for quantum computing to revolutionize AI enables solutions to previously intractable problems. Then we have neuro-inspired AI, drawing inspiration from the human brain to develop more efficient and adaptable systems. Then AI for sustainability, we try to use AI to address climate change, resource management, and other environmental challenges, for example, energy optimization. And last but not least, personalized experience. AI tailoring products, services, and content to individual needs and preferences, from personalized recommendation to customized healthcare treatments. Some computer scientists believe that once we develop a generalized AI or AGI at or above human level, then it will develop more advanced version of it by itself. This process is called as singularity. If this happens, then the resulting exponential growth in AI capability will rapidly transcend human intelligence, and we may find ourselves subservient to the machines. This is somehow a theoretical future, and we are not sure whether it happens or not. So the last is this powerful and thought thought-provoking quote by the late Stephen Hawking. Stephen Hawking said AI will be either the best or the worst thing ever to happen to humanity. This quote encapsulates the main immense potential and the potential risk associated with the development of AI. So he said either the best. Unprecedented opportunities like AI has the potential to revolutionize numerous aspects of our life. Medical advancements, solving global challenges, enhance productivity and efficiency, expanding human understanding, and new forms of creativity and expression. On the other side, he said, or the worst thing. Hawking warning highlighted the potential for AI to pose significant threats. For example, uncontrollable superintelligence, job displacement and economic inequality, autonomous weapons, bias discrimination, privacy violation, and many others. AI will continue to evolve, impacting society in ways we are only beginning to understand. Ethical concerns, bias, regulation will play a crucial role in shaping AI future. Thank you for your time and attention, and see you in the next lecture.